In example number 3, I'm asked to show how I could represent the area of that shaded segment. Now, the segment that I need to show the area for would be the area of the sector minus the area of the triangle. If I write that out, then I would be using the parts that I'm shading over here for the sector, and I would minus the triangle OAB. We would need to know both the formula for the sector and the formula for the area of a triangle. So in other words, the shaded part that I would need is the area of the sector, which is given to me by a half r squared theta, and minus the area of the triangle, and that is going to be a half, and that's times by the two adjacent sides, which is r times r, which is r squared, all times by sine of my angle, which is sine of theta. Now all I need to do is take out a half r squared as a common factor, and then I'm left with a half r squared and then theta minus sine of theta. The information that you need to find and show clearly was the step number 1, because if I say to you, show that this is in fact the case, you need to give me hard evidence how you got to that result. In part B of the same sum, the instruction is to show that 3 theta minus 4 sine theta is 0. At the moment, this seems very difficult for me to do. So what I'm going to do is I'm going to work in two parts of this diagram. The first part that I'm going to work in is in this triangle over here, and then the second part that I'm going to work in is the shaded area. Starting with the part that I've highlighted in yellow, we are able to find the missing angle AOC. As the angle that goes along a straight line, AOB, is pi, AOC is going to be pi minus theta. Now you can see that you can very nicely find the area of this triangle. So the area of the triangle, which is AOC, is going to be equal to a half times AO times by OC as half AO OC times by sine of my angle, and the angle that is included between those two adjacent sides is going to be pi minus theta. Filling in some information over here, I've got a half times r, which is r squared. Now sine of pi minus theta can very nicely be reduced. That angle is in my second quadrant, where my sine ratios are positive. In other words, I can write that as sine of theta. Now going back into my shaded part, and the shaded part is this part highlighted over here. In this part, I am able to use information that I got in part 1 of my question. Do you remember that we had a similar diagram in part 1, and we actually got that the area of that shaded part was equal to a half r squared into the bracket of pi minus sine of theta. Now I know that the area of my triangle is 3 times the area of the shaded area. So I'm going to now be able to equate both of these parts. So if the yellow part is 3 times the shaded part, if I want to make an equation, I must then times the shaded part by 3. In my next step, I'm going to do something that is quite clever. You will have noticed that in the part that I need to show, I don't have any r squareds. And so what I'm going to do is I'm going to times both sides by 2 all over r squared. If I do it to both the left and the right of my equation is still valid. So the 2's cancel with each other, as do the r squareds. In other words, I'm going to be left with sine of theta is going to be equal to 3 theta by distributing the 3 into the bracket minus 3 sine of theta. The statement that I needed to show was equal to 0. So in other words, I want to take my sine theta across to the other side. By doing so, I get that 3 theta minus 3 sine theta minus another sine theta, which is minus 4 sine of theta, is going to be equal to 0. So I have therefore proven the statement that they asked me to show.